How's it, grade 11th? Okay, today we're going on to exponential and log functions. Just to get some things out of the way quickly. So first of all, y is equal to a to the x. That is an exponential function where you know that that's the base, that's the exponent, and then that would be whatever the value comes out to be. Now, if I swap the y and the x, so we get x is equal to a to the y. That is an inverse exponential function. So you guys know how to find inverses. You just swap the x and the y around. But now here comes the problem. We never write an equation as x equals something. We always write it as y is equal to something. And what we can do is we can get the y on its own, okay, like this. And we say y is equal to log x base a, all right? And now this is a logarithmic function. What we can do is we can swap between these two things. So I can go from a log function to an exponential, or an exponential to a log. Now what I want you guys to know is I need you guys to know how to swap from an exponential to a log, and then back again from a log to an exponential, okay? So just take note of where the x goes, where the a goes, and where the y goes, okay? Now, why do we use logs? Well, let's have a look at an example like this. Now, you guys have seen how to solve for an x here. What we do is we get the bases the same. So we can say that this is 2 to the x is equal to 2 to the 3. All we do is just prime factorize that base, okay? And now, once our bases are the same, we can equate the exponents. So therefore, x is equal to 3 in this case. Now that's a simple case where we can get the bases the same. What about something like this now? There's no ways we can represent 8 as 3 to the power of something. We can't get these bases the same. And this is where logs come in. So what I'm going to do is I'm going to convert this into log form. So having a look here, so we get x is equal to log 8 base 3. Okay, so just use this. And what we can do now is we can use the calculator to help us find out what this answer is. So on your calculators, you're going to go log base 3 and 8. And we get that x is equal to 1.8927892261. In other words, if I take 3 to the power of this number, I will get 8. So let's have a look, see. So 3 to the power of whatever answer we got there, and we get 8. So you see, now we don't have to represent things with the same basis as we did here. We've got a tool now that can help us find out what this exponent will be to find the answer, okay? Now, what I've done is I've just photocopied the page from your book. So I'm working from this chapter over here, chapter 10, Exponential and Logarithmic Functions. And I've just photocopied the next page just to talk about it quickly here. So we're also going to use something called a natural log, all right? And your natural log is this thing here. Now, I don't pronounce it ln or ln, I just pronounce it ln. Okay, ln is ln, so it's ln x is equal to log x base e. Now, as soon as it has that base e, we use ln. Now, you're probably asking, well, what is e? E is just Euler's number, okay, and it's approximately equal to this thing over here, and we use it for natural logs. So if your base is e, you're going to use natural logs, okay? And it says here, y is equal to ln x if and only if. So that's not a spelling mistake. IFF stands for if and only if. E to the y is equal to x. In other words, your base is e. And now what they've done is they've just swapped between these two using this over here, okay? Now, I need you guys to highlight these and I need you to know them off by heart, okay? So rules for logs. So you have your product rule, quotient rule, power rule, and your chains of base. Don't worry about them too much now. I'm going to go through examples. Okay. Also, another important thing is the properties of your log. So if you get log A base A, in other words, if these two things are the same, it's going to be equal to 1. If you get log 1 base whatever, it's equal to 0. Then log A to the x base A is equal to x. All right. And then A to the power of log x base A is equal to x. Log x base 1 over A is equal to negative log x base A. And then we've got log B base A is equal to 1 over log A base B. All right. The above rules and properties are also applicable to the common logarithmic and natural log. Note the following, that ln E is equal to 1. Now, there's an important thing here, guys. I just want to put a little side note here. If I say this, log 5, okay, you've noticed there that I haven't put a base. Now, there is a base there, it's just invisible. And when you see a log on its own like this, the base is 10. Now, the reason why that is because we work with our counting system is base 10, okay? So, having said that, if I have this now, log 10, for example, now there's that invisible 10 there, and now I know from this property over here, log A base A. If those two things are the same, so log 10 base 10, we know that's going to be equal to 1. All right? Very similar to this. So ln E. Now you remember, the base for natural log is E. So we don't have to put it in there. So I'm just going to put it in red. So basically that's what it's saying. It's saying ln E base E. All right? And we know that's going to be equal to 1. Why? Because of this property over here. Now, all of these log rules and properties work for your natural logs as well. Okay? So ln 1 base E is equal to 0 from this. Ln E to the power of x, remember there's a base E, it's this property, which is equal to x, and then E to the power of ln x is equal to x, which is this property over here. Okay, so as you can see, your natural log and your normal log follow the same rules and properties. Okay, so let's go through some examples here. Okay, so example 1. And again, grade 11s, I'm working from these examples in your book here, if you want to follow in your book. Okay, so what have we got? So it's saying here using E is equal to 2,718. Determine the following in terms of E. So question A, we've got 2,718 squared minus 1 all over 3,718. Okay, so we can use this fact that E is equal to 2.718. So have a look here. We've got a 2.718, so I can change that to an E. What can I do with this though? With this one, I can see that I've taken 2,718 and I've added 1 to it. So that is going to change to this, and that is E. So this whole thing I can change to, that's going to change to E, so we get E squared minus 1 over, and then the bottom here becomes E plus 1. All right. Up at the top, I have a difference of 2 squares. I can factorize that, so we get E plus 1, E minus 1, all over E plus 1. The E plus 1s will cancel, and we're left with E minus 1. Okay? Now just remember, E is not a variable. Okay? It is a constant. It is Euler's number. And it is this 2.718. But I'm going to leave my answer like that because the question was leave your answers in terms of E. Okay. If we look at example B, we've got 4,718 squared minus 3,718 squared minus 2 times 5,718. 4, 3, 6. Okay, so with this one here, I can see I've got 2 plus this thing, all right? So this becomes 2 plus 2,718, and that whole thing was squared from there. Minus, this one over here is going to be 1 plus 2,718. So 1 plus 2,718, and that is squared. Minus 2. Now, this one over here is going to be a little bit tricky because this whole decimal over here is also not 718, 718. So we multiplied something over there. So I just want to see here. If I take 2 times 2.718 and we get 5.436. So this thing here I can actually expand to be, so that 2 is coming from there, multiplied by another 2 from that 2 there, multiplied by 2,718. All right, so what I can do now is I can change that to E, that to E, and that to E. And we get 2 plus E squared minus 1 plus E squared minus, and this is just going to give me 4E. All right, so grade 11s, if I expand this, I get 4 plus 4E plus E squared. I'm going to expand this grade 11s, but then I'm still going to multiply by negative. So we get here minus 1 minus 2E minus E squared minus 4E. Okay, so I'm just missing a few steps. Now I'm just going to get like terms together. So we see that the E squareds cancel. We got 4E minus 2 is 2E minus another 4E is minus 2E. Then, so those are gone, gone, and gone. Then we got 4 minus 1 is plus 3. Okay. Let's have a look at example 2. So they're asking us here, expand each of the following expressions by using the logarithmic laws. So question A, we've got log x squared, x minus 1 cubed, all over 2x plus 1, and this is to the power of 4, and it is base 2. Okay, so what we need to do is we need to expand it using these rules for logs. So I'm going to go through these and expand it, okay? So the first thing first, if we look at the top here, we've got this x squared times this bracket, okay? So if I have a look here, that's basically this one over here. We've got something times something, and it's with a log. If I reverse that, I must add the two things with their logs, okay? So that's the first thing I'm going to do by just using this product rule over here. So we get log x squared base 2 plus, because that's what this property is saying, plus log, now I'm going to do this one because it's multiplied, x minus 1 cubed base 2. All right, now I'm looking for a divide, and here is a divide over here for this property, and it says we must subtract. So this would be minus log 2x plus 1 to the power of 4 base 2. All right, so let's go through this again, grade 11s. We're multiplying there, so I use this one to expand it, so it's plus. Here I'm dividing, so it's dividing. To expand it, I subtract. Okay. Now we're not quite finished yet because I can work with this one, and this one by applying the power rule. So it says here, if you've got something to the power of something, what do you do with that exponent? You take it to the front of the log. So that's what I'm going to do here. I'm going to take this exponent, and that exponent to the front of the logs using the power rule. Okay, so this becomes, sorry, there's an ant, which is equal to, take this to the front, so we get 2 log x base 2 plus 3 log x minus 1 base 2 minus 4 log 2x plus 1 base 2. And that is it. We've expanded it. Okay. If we go on to example B, we've got ln x cubed y squared z to the power of 5, all in a square root. Now, remember grade 11s, my base here is e, because they've given us the natural log. So before I start going into this one, what I want to do is I want to get rid of that surd. So we get here ln. Now remember, we use this thing here. If I've got a to the power of n to the nth root, that would be equal to a to the m over n. Okay, so I'm just using that property there. So this will become x cubed y squared z to the 5. Now this whole thing was to the power of 1, and that is the square root, so this is to the power of a half. My m was 1, my n is 2. Okay, so what am I ready to do with this one now? So remember, your ln and your log rules work together, and the properties. So what I'm going to do is I'm going to use this property over here, your power rule. I'm just going to take the power to the front. So in other words, I'm going to take this half to the front, and we get a half ln x cubed y squared z to the 5. Okay. Now, this is all multiplied inside here. You've got x cubed times y squared times z to the 5. So I'm going to use the product rule by expanding. So I'm going to add each one of those. But just remember, we have this half outside here. So it's a half. And here comes my expansion. So it's going to become ln x cubed plus ln y squared plus ln z to the 5. Okay. Again, I'm going to use the power rule just by taking those powers to the front for each one here. And we get a half 3 ln x plus 2 ln y plus 5 ln z. Okay, now I can distribute the half in here, and we get 3 over 2 ln x plus a half times 2 is just 1, so we get ln y plus 5 over 2 ln z. And that is our expansion. All right, grade 11s, I think one more, and then I will give you some homework, and then I'll do a part 2. Okay, so let's have a look at question or example C. We've got ln sine squared x times by ln x, all in a square root. Okay, again, I'm going to convert that surd. So we get ln sine squared x times ln x, all to the power of a half. All right, take the half to the front, and we get a half ln sine x times ln x. Okay, what I can do from there now is, because this is multiplied, I can split that using that product rule. So we get ln sine squared x plus ln x. Okay. Now, the squared I can take to the front. So we get a half 2 ln sine x plus. Now with this, the ln x, there's nothing we can really do with that, so it just stays ln x. Okay? What I can do now is I can multiply in the half, and a half times 2 is just a 1, so we get ln sine x plus a half ln ln x. And that's your final answer expanded. Right, grade 11s, let's have a look and see what we can do for homework here. Here we go, exercise. Okay, so what you can do for me is you can do number 2 for me. And then, yeah, let's start with number 2, okay, from the exercise. All right, thanks, grade 11s.